So what we're looking for here is this plating between these two that come up and over, that wrap around the top outer surface, is what we call wrap plating. That has to be the minimum thickness for a minimum distance. The requirement is that has to be at least 2/10 thick when we're done. So as we do our planarization down with that process of sanding, we're trying to take everything off that's not supposed to be on the panel. We can't go so far that we just go all the way through all the copper. We don't want to do that. So then after we do that, we're going to go and we're going to drill the rest of our holes in the board, all the through holes. Maybe you got a connector, a little connector, something on there. Now we got to go plate those holes, and they need to meet their minimum thickness as well. And so that's this extra plating you're seeing on top. So in a lot of cases, there's the wrap and then what we'll call a cap plating over the top. It could be that this via doesn't even have a surface mount component on it, but it's built so that there's no transfer of air through the board for a number of different reasons. Or there could be a component that's on top of this. So what you can see here, though, over this details, we started out with our community sounds, so roughly 4/10 of mill copper there. We've got our wrap plating. We got to need a 2/10 minimum. We all trying to get back close to that, so you maybe have a couple more tenths there. The dot plate's gone in this case by the time on the top. But we also have a through hole plate of a mill and a quarter to a mill and a half for the rest of the holes in the board. So you see where we started with 4/10 copper. When we're done, we're pretty much at 2 ounces of copper here. And now, usually on this outer layer is where you also have all your fine pitch components. So we're going to be etching fine patterns in 2 ounces of copper. So this is why we'll come back and ask, hey, can we start with a thinner copper on these outer layers so that we can manage this better? And so some things we'll say for that is, if it's a single plating cycle, 5 lines of space is it's pretty good for that. If we have multiple platings in that outer layer, so if you do what we're showing here, the other thing we add to this is if we have microvias, those get lasered and plated first. Actually, they get plated second. So the cap and wrap holes will get done first, then the microvias, and then the through holes. So the more different via structure we have in the outer layer, the more different platings there could be. And that can really drive some line width and spacing issues and challenges that we can have from time to time. And so we'll work through that with you. And parts that have multiple microvia sets in them or via structure in them, you have multiple layers in your part that we would call an external plated layer. So we have to think through how those are going to get etched and make sure they can be done. In general, on these types of products, we are not going to want to use nickel gold as an etch resist. In other words, we're not going to want to do a full body plating on these jobs. And that's because the amount of overhang you have when you have to etch so much copper, you have the nickel gold overhang the edge of that pattern that we etch, and you can have a little flaking around the edges. We don't want that. So most commonly what we see on these boards is we're going to etch them more conventionally, and then afterwards we're going to come back in and do an ENIG process. Now you can etch it in ENIG and then solder mask if you want, or you can etch it, solder mask, and then ENIG. And there's pros and cons to that. All depends on the design and some of the other features on there. But you may get in some cases, the manufacturers say, hey, we want to put the ENIG on before solder mask. And the reason for that is, in some cases, some of the boards may have a solder mask, and it just says just solder mask fill and coat the vias, for example.